Okay. Alright, so we've almost finished everything of the semester. Almost, but not yet. Yeah. So, yeah. In order to make it go more smoothly at the end of the semester, well, today I'm gonna go through today's material, and also I want to have some Q&A time, so that I can answer, like, if you have any question regarding any of the week's material. Okay. So last week we talked about the design patterns, right? So I introduced a set of them, subset of the design patterns. Right. I don't know if you still remember them. So the first thing I introduced is the observer, which is the very first design pattern I was using, because I was trying to do some doing some UI at that time. So I trying to make this observer. It comes again. Yeah, I saw you can see the thing. Right, observer. Do you remember? So that's basically, yeah, try to memorize it, publisher and subscriber. Okay. So that's very common relations between especially the services. Okay, or if you have some in the real life, you got the message, email, this or your social network, all of them have the push services. So the push services is kind of like this observer, because whenever something's changed in your account, it has some push to your phone or to your application, to the client, so that you know what happens there. Okay, and in order to implement that, in Java we actually have this observer. Actually, in Java we already have the observer defined there. But if you want to implement that, you need two things. One is the observer. One is the subject. Subject provides the services. Observer is the client who receives the services. Yes.
So you're saying Java already has that built in?
Yeah, I believe so. I believe Java has the observer, but you need to check more details, because I haven't used that for a long time. But it should be there. And if you, even if it's not there, if you want to use it, it's pretty simple. Just two things, two interfaces. One is subject, one is observer, and there are maybe in your system there may be a whole bunch of subjects and another set of observers. Okay, but they all work the same way. Okay, if it's the subject, you should at least to have functions to register the observer, to know who is subscribed my service, and you should have the functionality to notify all the observer. Okay, something changed. When you are notifying the observer something changed, like here, yeah, it's actually calling this function of the update function of all the observers. So you hold a list of observers, so I know who is subscribed my services. Whenever something changes, I pull the list out and tell everyone update, because I changed. So I have this new services, new information, new message for you. Alright, so if you still cannot remember them, the sample codes are here. Sample code is not here, but sample code is available through the website I provided last time, and we have template master. So yeah, that's the website I mentioned last week. Yeah. So all this design patterns, they are kind of way people are doing this. People are solving the problem this way, and so they kind of summarize this kind of pattern to help with a similar situation. And you can apply this design patterns to different scenarios, like if you're doing the networking, probably the observer probably it's better idea for networking services, and we can apply that for UI. Sometimes you just have that in mind, and you can decide which pattern is more applicable to your current situation, to the problem you are currently solving. Okay, but before that, you need to have this in mind. What are the patterns that are available there? Or you can kind of mix some patterns, make your own pattern. That's workable, right? But if you're using the design pattern, that means you're reusing the experiences from lots of other engineers, software engineers. So it's a good way to ensure your quality of your design and of your product. Okay, so that's about the design patterns. Have you learned any design patterns in any other classes before? Okay, yeah, design pattern itself can be an individual course. So if you're really interested in that, which I'm very interested in that, so you can go ahead and do your own research on those design patterns. Yeah, that's reusing good experiences from a group of who are from the community. So it actually can help you. And when you are trying to use design pattern or trying to mimic a way people design a design pattern, okay, you are applying all those object-oriented principles automatically there. So, and sometimes okay, the principles is, I want to separate the changes, encapsulate the changes, but how am I gonna do that? Maybe sometimes you don't know. You just think, okay, I put it in a separate class, but does it help? Sometimes you know the principle, but you don't know how to do it. And when you kind of know all these patterns, you will have a better understanding to those principles, and you may generate your own patterns there. Yeah, it's not something like the principle, and you can have a very good design of a system, something like that. Okay. I don't think just one pattern is missing. Maybe it's called singleton pattern. Singleton pattern means for the classes that build with the singleton pattern, you can only have one instance of that class. Okay, you don't want more. Like usually you can have multiple objects built from one certain class. But with a singleton design, you can only have one. How do you control that? You do not use the constructor to initialize this class. You use this maybe class dot shared or class dot instance. So within that method, it created an object of this class. Okay, so the control is not by you. You cannot control. Okay, I'm gonna have a bunch of instances of it, but control is there in the class. It creates only one instance for that class. There are many situations you want to have only one instance, like especially when you're doing the UI. Okay, when you're doing the UI, you don't want to have a create new button. Okay, you want button just stand there as a button. You don't want a whole bunch of duplicates there. And also maybe the main page, you want to have only one. And sometimes you have like a master class or a class that coordinates all the rest of the classes objects. Sometimes you want that to be a single class, a singleton. You want them to be a single instance there. Or is there something that actually we have only one of them? We create only one object with a singleton pattern. Yes. And factory is another way. Factory is like it works as a factory. It creates a whole bunch of instances similarly. And you describe what kind of instance I want. Like the factory, the shape factory. You kind of have a circle, square, and rectangle. So it creates the objects per your request, per your definition, your settings. So if you want to create a circle, then you just do a circle. You specify, yeah, I want to get a shape circle. It will return a circle to you. Yeah, like this. Alright, so that's a design pattern. If you're interested in more design patterns, yeah, you're welcome to search for many more materials there. Alright, today we will talk about, we're going to continue our discussion in the UML, but instead of state machine diagram, class diagram, now we are focusing more on the interaction. Let's take a look at the interaction UML, so the sequence diagram. Okay. This one. Make sure it's on the screen. Yes. Well, so far we have learned class diagram, right, and state machine diagram. So state machine diagram is more dynamic. It's model the system, how it reacts to different requests. So whenever something happens, how the system reacted to that. And remember, where is the state machine diagram? Where is the state? Where do we put the state machine diagram? Yeah. Yes. So basically, it's within each class. Okay, it's within each class. Every class can have a state machine diagram because every class has its state. The state is determined by the value of the attributes of the class. Remember that? Like a computer class, we have a switch on and off. So that's two different states. And when it's switch on, when you are running some fancy games, 3D games, okay, the GPU is in use. But if you are watching the video, the GPU is not in use. You're using another integrated like graphic card there. Sometimes your computer has two graphic cards, you know that, right? One is integrated, one is a separate individual graphic card. Okay, so that's two different states. Like when you switch on, that's a different combination of the attributes, right? On is one, on and off, that's one of the attributes of your class, of your computer. And GPU is another attribute, and integrated graphic card is another attribute. Okay, so different combinations, the value of different combinations of the value of those attributes will result in different state of your computer, right? And under different state, your computer reacts differently. For example, when it's in the off state, when computer is in off state. When you press the power button, it turns on. But when it's on state, when you press the power button, it turns off. So different reaction. But when it's in the off state, if you press the space button, it does nothing. Okay. But when it's on state, it does something there. So we have dynamic behaviors modeled by the state machine diagram. Okay, if you forgot what are state machine diagrams, you can go back, watch the videos I posted, from the class. Okay, and now we are going more dynamic than not dynamic. We're going more like we want to model the interaction of all these objects between these classes. Okay, and the actors, the classes. So interaction diagram illustrate how objects interact. And it's also a dynamic aspect of these objects. So above all the UML diagrams we learned, only the class diagram is static. So the other diagrams, they are more dynamic. So here is another dynamic diagram, sequence diagram. And two types of interaction. One is sequence. We will focus on this sequence diagram. Another one, you can remember the name, it's called communication interaction diagrams. But that's not what we are talking today. So sequence diagram looks something like this. We will have objects there and timeline of the objects, and then so if you see here this A, what is the A? Guess. Yeah, that's the type, or you can say the class, the name of the class or the type. Okay, and my B is my B is the object name, and B is its type. Here we have this object area empty. It's because maybe it's unnamed yet. Okay, and we have this arrow from maybe pointing from one line from one object to another object. That means it's sending some message and doing something. Okay, and those dashes means the timeline that this object exists there. Okay, and all this rectangles, this rectangle here means this object is active, is alive. Like this B, my B object, it exists there in the system, but it's not active until it receives something from A, like do to, and then B does something. When it's finished the work, it goes into the non-active state. But as long as the dash line is there, that means this object exists there in your memory or something like that. Okay, and it goes to idle again until it receives another thing from A called do 3, and B does something. So very easy to understand. Any question?
That rectangle there represents a dormant state when it's not doing anything, or?
That means it is working. It is working there. Active. It is active. Well, okay. So here you say do 2. Okay, but between the do 2 and do 3, it really doesn't have anything there. That doesn't mean it's not working. It may run in some algorithm to calculate something, and until a step is like, okay, I'm gonna do 3, and it sends a message out. Okay, so here in between, if it's not dashed line, that means it is working. All right. Yes.
What do you mean by it's working?
It's active. That means
There's no dashed line between on first big square.
I mean this here. yeah, if it's okay, here's a dash line.
Uh-huh.
Dash line means it exists there, but it's not active. Means like the A wants
It's
B to do
finished.
something, then B does something. B does this 2 here, it finished the do 2. Okay, then it has nothing to do. It goes something like idle.
Is
or-
that like indicator of the time? How
yeah,
long it is
that's the
active?
time. That's the timeline.
So what if it could it be like the whole thing was one square on the other side, and that means that it didn't finish?
No, the whole thing. This one square, the whole square means A is working basically all the time here, and then some step A saying, yeah, I'm gonna do. I have something I need to ask about to B. Then it sends a message to B, and B said, okay, I received the message. I'm gonna give you some return, or I'm gonna generate something, generate my work. Okay, and then at the end of the rectangle, B finished that job. And before A sends another request, B has nothing to do. So it's kind of idle.
Oh wait, so you're saying so it goes this way and then this way as well.
Yeah, yeah.
Okay.
Okay, yeah, from top to down, it's timeline. It's a
Okay.
timeline.
Oh.
Yeah. So
And
do
what
2 is
about-
before do 3. Do 2 is before do 3. And do 1 is before do 2 and do 3.
Okay.
Okay.
So it's
Yeah.
always like these little squares on the other side. It's never like one solid square.
No, sometimes it has some solid square. Maybe B is interacting with some.
Oh, okay, so
something
if it
else.
was like if you had like first A, then B, then C, then it would be another big square there because they had another task to do, and then once they finished the task, then it would be a square like this on the last one.
Yeah, I don't quite get it because you pointed. Yeah, but
You don't.
but the principle here is, well, it reflects the relations between all these operations in a time manner.
Because my question basically is, can it be another long square, or is it always on the next one? Do you have these tiny little squares?
It can be a
Finish?
long square, yes. It can be a long
Okay.
square. It's okay.
And that
It
means
all
you
depends.
finish the task.
If there's no dash here,
Process. I don't think it's just about that task. If it is processing something or
Yeah.
not, it will execute.
Okay, so if it wasn't finished processing on the other side, it would still be a long square.
yes,
Yes.
yes.
Okay.
If it's finished processing, it has
Okay.
nothing to do. It becomes idle.
Okay.
Yeah. So that also depends on the time, and also if B is doing something interaction with another, if it's doing some interaction with another project. Yeah, we can see more
I don't
examples.
think this is a very accurate this thing, right? Like it doesn't accurately depict what is happening. I mean, like when A is sending the request to B and B is processing, A
Okay,
might be idle
yeah.
at that point.
In real time, so this is just the modeling the situation, maybe an ideal situation. In real world, when A sending do 2 to B, maybe do is keeping doing this. When A is doing do 3, when A is like sending do 3 to B, B haven't finished do 2 yet. So that in that case, it's gonna be just a single integrated.
No, like
rectangle.
even A, if it sends the control to B, A might not be doing anything at that point.
Oh, yeah.
Right? It'll be idle.
Yes.
But we don't
Yeah,
show that.
We can have this idle as well. We can like we send it to do 2, and then we can become kind of dash line here until B have some feedback here. It active A again. So that's gonna be a single thread. That's gonna be a single thread.
If this was dashed on the first one, then it would have to have some feedback from B to continue.
No, it
down
doesn't
the
have
path.
to. It doesn't have to. So let's see more example. You'll get the idea. So it's flexible. You can have dash or not. Just depends on
Okay,
the.
so let me see if I can help. So let's say you are just for an example. Let's say you have A is calculating the height for 2 people, right? And so you start A, and you have 2 or 3 or 4 numbers that you have to calculate 2 each for 2 people, right? So you start A, and A will have to call, let's say B, all B does is calculate the height of people, right? So you call A with the 4 numbers you have, whatever data you have.
Mhm.
And so A is running and A calls B and say, hey, I have 2 numbers, give me the height for this guy.
Right.
So it returns the height, and then, but while B is working, A is still in memory, right? Because it's working, it's the application, the program that is sending the call anyway. So it's still there, but it's just not calculating anything yet, but it's still in memory. So when B returns the first guy's height, A calls again the second guy's height, and that goes back to B again. So do 3, and it goes back and calculates the second guy's height and return it to A. And so by the time B does this twice, then A has all it needs to do, and that is the end of A.
So with that, sorry, I
Yeah, go
don't
ahead,
want
go
to
ahead.
keep the class like.
That's
but-
okay.
But so is that? But that's if it's active, isn't it? That's why you have the continuous.
Yes, so A is still running,
what
it's
if-
in memory.
Right, but what if it's like? What if it's because the professor said that it can be not active, so it can be the 2 squares separated on the
Yeah.
first one
Yeah.
without having any feedback. But
Yeah.
the problem, I don't have a problem with it, but the question I have more is, if it was 2 separate ones, if that symbolizes that the process was finished, then how can it go downwards to the next one without feedback from the first one?
Feedback.
I think that's where the next
Okay.
log would
Listen
begin.
to.
That's what the next log
All right.
Sometimes it is implicit,
It
but
can
suppose
be
like
the
the-
feedback. Yeah, it's 2 situations. One is it doesn't require feedback at all. The other
Okay.
situation is the feedback exists, but it just does not modeled here. Because if it's sequence diagram, you sometimes you model the thing you're interested in. You're not modeling everything. Maybe it gives us feedback, but it's not showing there. Or it's something like just do not need feedback. Okay, let me give you another example. So if you think about in the operation room, in the doctor and all the assistants there, so the doctor is keeping doing this procedure, like doing this cutting, getting something out. Okay, so the doctor is never the doc usually doctor won't stop just doing that. Okay, give me that clamp, give me that scissor, give me the something. Okay, so and then you push you give the blood, you've got blood in, and you doing the clean. So doctor is keeping sending all those commands to the other nurses or assistants, right? But doctor never stop. So it's like more like this kind of situation. Like you give me the scissor, give me the after my assistant give me the scissor. Okay, I got the scissor. Maybe he doesn't have anything to do there at all,
Oh, they
but
just-
he stand by there.
Right.
This means maybe the dash line is same thing like
That
the stand
means
by
that
there.
they're separated. They're not one continuous.
Yeah, one continuous because
No?
yeah, because I have an assistant. Give me a scissor. He give me a scissor. Then I do something. The scissor
And
is
this is- I know
broken.
that one.
Give me another scissor. Okay, but between he give me these 2 scissors, he's
Right.
doing nothing there.
Okay.
It becomes a dash line.
Best
Yeah.
example for a software
Something like that.
breakdown.
Okay, let's continue.
And more new examples
Okay,
like
but
still
still-
doing it. Yeah.
This is a very good example.
Yeah, yeah. Doctor and assistants. Think about doctor and their assistants. Yeah, and your insurance maybe. Okay. That's communication diagram. Communication diagram is a different style of this interaction diagram, but they reflect the similar information there. Yes. Okay, so this is another sequence diagram. The message make payment is sent to yeah, okay. So first, let's make payment. Let's register object. One of the register object get the make payment message from another, maybe out of scope of this sequence diagram. Maybe it's from a actor, from a person, or it's from the user interface somehow. But somehow it gets this message, and after it get this message is what we care, what we're interested in. Okay, so it get the register, get the make payment. So what the register does is it send a make payment and another message to the sale, and sale actually create a payment object. So message here, I'm just want to say, it's message. It can actually create the object. Okay, so from here, if we think in a time manner, in the beginning we have two objects, a register and a sale, two objects, but the payment object doesn't exist. Yeah.
So sale is creating the payment? So
Yeah.
sale is the fact.
Sales create. You can create an object from another object, right, during runtime, right? Yeah. So here, this actually reflects that kind of scenario. It means we can create an object. The object came into existence at the moment the sale sent this message, or the sale does something to that. And you can, when it came into existence, you kind of put that square there, say, okay, here's another object, and it's going to do something else, but it's not there on the top because they don't like create it at the same time. Okay, so payment is created after a while when sale receives a message and react to that message. Okay, that means within a sequence diagram, you don't have to put all the objects all at once on top. And maybe some object is created in the process. All right.
The length of the square, does that have to do with how long the operation is active?
Yeah, it's sort of related to that, but it's all a relative. Okay, it's not saying if it's like this long, that means 1 hour processing. But if it's like here, if it's maybe it's longer, register is longer than sale, that means at least the register has a longer processing time than the
It's
sale.
kind of just like
Yeah, so it's all relative.
right.
Yeah, and the register, so this is a reading of that. The message make payment sent to the register, and the register instance send a make payment message to a sale instance. The sale instance creates an instance of payment. So that what happened in this diagram. Yeah, this is kind of the code, the sale class. So we have a make payment, and during we are doing make payment, the payment is creating a the sale is creating a new payment instance here in this line, new payment. So here is a comparison between the interaction diagram and the class diagram. We will know the differences there, right? One of them is static, one of them is more dynamic. It reflects the interaction between those two objects. But in class diagram, we know the relations of these classes. Maybe it's inheritance or has a relation aggregation. Like I have a sunglass, that's a has a relation. Right? But I inherited my I from maybe my parent class, right? Yeah, so class diagram is just a summary static view. It's a very easily created after the interaction diagrams. Yeah, and coding will be much easier from if you do it from the interaction diagram, because the interaction diagram basically it reflects the order, like when they are collaborating, when all the objects are collaborating, and you have more details of this interaction, right? Like creating a new object, you know that that's a place you want to initialize the new instance from a class. and class diagram shows more about the structure. And both of them are useful. I'm not saying one of them is bad, one of them is good, but both of them, they are all useful, just in different situation. Okay, it's stuck. So this is the introduction of, I need to make it smaller. Of the notations of the sequence diagram. Well, this is better. Alright, so that's an object. So lifeline box representing an unnamed instance of the class. So if that's empty, that means we don't have a name. But if we have S1 there, cell, S1 cell, that means it's a named instance. And also, well, if it's named, that means you have more detail when you're doing this implementation. And lifeline box representing the class's font. Or more precisely, the font is an instance of a class. An instance of the meta class, so it's some special class there. Yeah, it's similar to, but it's just a font. Meta class is gonna be the meta class is the not superclass. It's a interface. You can also call it superclass. Well, interface is pretty similar to superclass, but and font is like a subclass, or it's maybe an instance. Not instance. Font is still a class, and the meta class is the instance of. No. Sorry, I'm confused about instance and interface. So meta class is the interface. Okay, you all know what are the interfaces? What are those? Right, we talk about interface a lot. And here is a cells is the instance. And we have an array list, so a list of cell. So it's gonna be a instance of that list. Okay, instance of that list. And here we have the cells with index I. That means one single instance from that list. All right. And here it means list is an interface. So you use this X list to create kind of like abstract list. Like you do not have like it's a list of sale or it's a list of something, but just the interface there. And most of them we're not using them a lot. Most common ones are those cell and S1 cell. Okay, so the object dash lines and boxes.
That little circle at the end of that line, what does it represent?
Circle.
Yeah, that's there.
This circle.
Yeah.
This circle is not. No, this circle is not a UML. It's just tells you this is. Okay, this is a notation I put there. It's not UML.
What about the one that's in the middle now? It has those two horns. Is that
This thing? Okay. All right.
No, let's just do that.
This, all these things, there are notations for you to understand them. Okay, only this part, only this rectangle and this dashed lines and the things within this rectangle, they belongs to the UML sequence diagram. Those are notations or comments, which doesn't belong to the syntax. Yeah, and also you can define different things there, give more information there. For example, you can define what is the message looks like. All right, you can see the example. Let me show you the example of the diagram. Okay, here. If we say something like, okay, it's get date, and then sales return date, that's fine. We can understand that. But D1 equals to get date. That means this request require a reply, a feedback from the other party. Okay, and the feedback is going to be stored in D1, or D1 maybe receives the feedback. Okay, like when you're calling a method, that method have a return value. You have to have, not you have to, so most of the time you have a instance there, or you have a value placeholder, something like that there to receive that return value. Okay, so D1 is, well, if you say this kind of D1 equals to something like this, that means it's requires a return. Okay. So if you see 1 here, that means, yeah, the singleton we just talked. If you see a 1 here, that means this is a singleton class, which means that class only has 1 instance. It's just some special indicator of this special special class. Okay, and you can only, well, for all the singleton classes, you access the object through the class, through the singleton access pattern, not through you initialize. You are not initialize this class. Okay, you call the store.shared or store.instance, or you can call something else you implemented, or store.give me an instance, something like that. You get the instance of the store. Yeah, so this is an example of singleton with the 1 there. Okay, so it's another my kind of message. We've talked it. So we have a found message whose sender is not specified because we do not care. It's not within the interest of this sequence diagram, so we do not specify the sender of the doX. But from the point the register received this doX, that's the thing we want to care. So here the register send the do A to sale, and sale do something, and send do B to sale do something, and this is the execution specification bar, indicates the focus of the control. Okay, so that means, like I said, it's active. And when it sends the do C message to the sale actually generated a message and send it back. Like the sale it's do D is not a reaction to do C. Okay, do D is something just like this sale ask the register to do. it's not associated with do C. If do D is a reply of do C, we have some other scenario. We have some other template for that. But here do D is different. Okay, so when you send do D, when the cell object like send message of do D to register object. So here we can see it's another rectangle, another bar created there. Okay, you can do it this way. It's more clear that because the cell object sending a message there, which result in something happens in the object of the register. It clearly indicated that. You can just remove this bar. It's okay. Well, it's still meet the requirement of the sequence diagram. But if you put an additional bar there, it makes things more clear. Okay, but it's just optional. All right. Yeah. Many of the details of the notations are optional. Yeah. Sometimes some of the tool it doesn't have those options at all, but don't freak out because they're optional and we can still understand if it's not there. Just makes things more clear. Okay, and then go to the message returns. There are two ways to indicate their return messages. One is using the message syntax. One is using a reply message line at the end of the activation bar. Okay, let's see, that's the two ways here. Okay, so here D1 equals get date. It's gonna have a similar effects with this message, get date, and then we have some reply message with the dash and the direction. It returns a date, or something like that. So both ways they work the same way, just two different representation of the sending message and get reply message. Okay. But they work the same. They have the same effects. Yes.
Are you saying they can be used interchangeably, or?
Yeah, they can use it
They have
interchangeably.
different design implications, right? Like one saying you need to store that in a variable, and the other one's like
Yeah.
make the request.
One said you have to store that in a variable, but the other one didn't see that, but it doesn't exclude that option here. It just says, okay, I'm getting this reply, but I didn't say where should I store that reply.
The other one above it, that's kind of right.
Yeah, here this one it gives you another information like we have a D1 to store the reply. Okay, and also if you're doing this way, you need to make sure that this dash line here, dash line and the direction, it should be at the end of the bar when it's finished the execution. Alright, let's finish the execution. Or actually, the second way gives you another option. Maybe we have a third object there. Okay, so when register send the get date to the cell, and cell send to another request to the database. After that cell doesn't do anything. It's just been dash dash dash, and until it receive and then return from the database. Then it becomes active again. At the end of the activation, it sends a date back. Okay, so that gives you more complex information. Like, well, and we know that the cell is going to receive message, but we also know the cell is going to talk to someone else to get it. But when it's requesting information from the third party, it becomes deactivated. It's not working. It's waiting. Until it getting something back, it gets a return message, send a return message to the register. Or different implementation is it says, okay, I get it, and then it returns something. Yeah, I request to send. Then it sends some request to third party, and then it returns some new actual request. But all those information, if you select the first syntax, it won't be there. Okay. So it depends on if you want to model this information to that kind of detail. If you do, you need to select different ways to do that. It's just a tools for you, but if you use it or not, or what kind of tools that you want to use, it depends on the thing you want to model.
Yeah, I was just thinking like maybe it's a good idea to use one over the other depending on what you're trying to communicate to the person that's building it out. Like you don't really want to tell them D1
Yes.
get date. It's like some huge object that
Yes.
you want to make a copy.
Yeah. Especially for the first one, maybe you don't care about the sequence, like sending message back and forth. You just want the other person you're communicating to know that this is getting something back. Okay. But here you can have way more details of this thing. So, well, sometimes details it helps you with the implementation, but sometimes when you are communicating with the other person, you want to kind of get rid of the details. You catch what is really important there. Maybe the other party just want to know, yeah, this is getting some reply. That's it. I don't care if it's gonna sending, if you are sent to the third party and if you give me a reply message before confirm message before reply message, something like that. Yeah. But this second way gives you all the other options there. Yeah, you can call, yeah, what's very common for a class to send a message itself, to call some method from itself. So yeah, you can also model this activity like you do X and do some clear and some execution here. Okay, this doesn't mean if whenever an object is calling a method of itself, you have to make it, we have to draw a line and box here. It doesn't mean that. It's just say, if you want to model this activity, you can use this kind of loop to model like self dot a method or this dot a method. But in Java, it's going to be this. In Swift, it's going to be self, something like that. Yeah. I believe most of the time when the when one object is executing, it more or less calls the method from itself, right? But you do not have to always modeling that. If you want to modeling that or not, that depends on if you're interested in this kind of self-invoke. Okay. Creation of the instance. Come on. Yeah, so the sales create this payment, and then it does something to the payment, and the height of the payment, it appears at the moment that it's created. So you can know relatively which class exists before another class, or which class is created after the existence of some other classes. Okay, so you have all those informations. And the lifelines and the destruction is simple. You just use this cross. This cross here indicates I'm gonna destroy this object. Do not use it anymore. Maybe it's initialized by some other object. Okay, but somehow you just want to destroy it and release the memory somehow. Okay, and we also have frame, so it's gonna be more detailed thing there. The frame means a region of diagram that have a operator and a guard. So here, this is like a frame. Okay, this loop thing is like a frame. It calls a loop, means that works as a loop. When the more item, when this kind of more item is called a guard, or you can call it variable or condition. When this is true, this loop continue executing. So it's just doing enter the item and it returns some a description. Enter item, return description, and item description until there are no more items. It's jumping out of the loop. So that's just a loop. So you can use sequence diagram to model the loop. And here you can, it's actually doing something there, right? But the bar of activation, the active bar is not there. This means, well, even it's active, if you do not care about the information of the activation or not, you can choose to not putting this activation bar there. So it's okay. It still meet the requirements of the sequence diagram. Optional. Yeah. A lot of them are optional. Right. A lot of them are optional. And that's a loop. So this is a type of frames. The loop is a fragment where the guard is true, and can also write loop to indicate the looping n times. Loop n to indicate loop n times. And we have some other things like alt. So it's alternative fragment for mutual exclusion condition logic expressed in the guards. From this description, do you know what is that? Well, it's described so formally. It's just if else, right? But it describes so formally, mutually exclusion, because if and else, they're mutually exclusion. You can either go to if or else, but not both. So OPT opt is the optional fragment that execute if guard is true. What is that? Yeah, just if. And par is a parallel fragment that execute in parallel, and region is a critical region with which only one thread can run. That's like multi-thread thing. Let's see. Right here, it basically equals if color is red, we do the calculation. If color is red, we do the calculation. If color is not red, this whole frame, this whole section will not be executed. And this is out, which means the if else, right? You see the if else. So we have two mutually exclusive parts. One is if x less than 10, we do the calculation using the object of b. Else, which means if x is greater or equal to 10, that means else. We go to this, we use the object of c to do the calculation. Right. You don't see that all the time, right? But it's just something that gives you the option to let you model a lot of the information there. So if you have this out there, it's even more clear how do you implement all these classes, right? You can directly transfer, because this is detailed down to the level of if else already, right? and the loop. Yeah, you can use an action box there to even indicate the I++. You'll understand that that is in the loop, right? So we don't need to mention more about that.
It seems unnecessary.
No. It's maybe you can say I plus equals 2,
I guess.
right? So that's different. Different looping action. You can have different looping action. Oh yeah, okay. Also, you can nesting of the frames. See here. So when the color is red, you're kind of looping n times for the n. Well, this kind of nesting can be replaced by some other loop condition or something like that, right? Color red. But also, it's just the example that show you all these frames. They can be they can be nested. Actually, I do think when you are doing this nesting, when you check it from the code, it's not as clear as when you check it from the sequence diagram. Because in the code, you say, okay, I have this if statement in class 4, but I have something else in the class bar to do the loop or something like that. So sometimes it's not very clear if you read the code, just reading the code. But if you're using this kind of notation, it's going to be more clear. You know that we have a loop. In the loop, we have this kind of operations, this calculation operations, and we know the scoop, which frame is outside of another frame, and which frame is included inside. So it's more clear, right, for you to understand the whole system, how the system is working. So it's gonna be a good tool for visualizing your code as well, right? So you create your code. Sometimes you create your code from the sequence diagram. Also, you can, like, when you want to communicate with others about your coding, you can create a sequence. If you do not have any sequence diagram, you can create the sequence diagram from a code so that the others knows the structure of your code. Okay, the structure of the code, not the structure of the system. Structure of the system is represented by the class diagram statically. Yep. So that's all about the sequence diagram. Well, every notations of the UMLs, they are all very simple to understand. Nesting, the loops, the frames. Okay. However, it's really just providing you with the tools to help you represent the model of your system, help you to visualize your design. So, but how do you design? There's still, well, it's a long way to go when you're coming with a good design. You have to fully understand those principles of the object-oriented programming thing. Yeah. So those are tools help you to show your design, but the idea of the design, you still need to stick to the principles. Okay, so we still have 5 minutes. Any questions regarding sequence diagram? And yeah, and how about those design patterns, those object-oriented stuff? Okay, let me go back a little bit. Okay, so I have a very good article here. Where is it? So we kind of basically learn most of the things in the semester. And here is the article. It's in the D2L. So it's a very good article. Talks a lot of aspect on the principles of this object-oriented design, which you've been already exposed to them. Those principles, like I think most importantly, how do you encapsulate stuff, encapsulate those changes. How can you be flexible to the changes, to the future maintenance of your system, right? So that's that's the core of the OOP, object-oriented programming design, OOD, or yeah. So for this article, I want you to go back, read this article, and we have a quiz, which I just want to make sure that you read this article, right? So don't freak out, don't be stressed out. So it's a quiz, or you can say it's a practice, but it's just I want to make sure you read it. After you read this article, you kind of need to answer the questions of the quiz, so that you have actually this article will have built up a very good understanding to this object-oriented design, help you to summarize a little bit of what we have learned and kind of apply them a little bit. So I want you to spend this Wednesday to read this article and finish the quiz, and next Monday we will talk about this article. Alright, so we won't meet Wednesday. Alright, so I want you to spend some time really carefully reading this article, like line by line. Alright, yeah. So that's it for today. Any question?
Did you say we're not meeting?
Well, we're not meeting Wednesday. Yeah.
Okay.
So you spend Wednesday reading this article. Alright. Alright, I'll see you next Monday. We'll talk about this article, okay? I want everyone to answer, to give me some of your understanding to this article. Alright, be prepared for that. I will ask a lot of questions.
All right, thank you.